Welcome back to another awesome video. Today we are going to go through moles and gases. How do we deal with moles when it comes to the state of matter, if the state of matter is a gas? So today we are not focusing on solutions or liquids or anything like that. Strictly dealing with gases. So these rules, these concepts, when we go through them, make sure you only will apply them to gases. So first of all, a few things that you need to remember. When dealing with gas, it's the only state of matter that is compressible. Remember, we have all these particles that are spread out all throughout a given amount of space. So what we can do is we can actually compress them fit into a smaller space. So that allows us, or that makes us take into account things like the volume of a gas, the pressure of a gas, as well as what's the temperature. So you don't really care about those as much with liquids, solids, things like that, because again, these aren't going to have much of an effect because the volume stays pretty much constant no matter what. The pressure doesn't really do anything because the particles are already really compact. So these three we really focus on with gases because they're going to affect how far apart the particles are, how fast they're moving, things like that. So one thing that if you remember from first year, is we have something that's called STP. And STP refers to standard temperature and pressure. So remember, if a gas is at STP, standard temperature and pressure, then the problem becomes very easy. Because I know at STP, if something is at STP, I know that 1 mole of any gas has a volume of 22.4 liters. So 1 mole of any gas, if the conditions are standard temperature and pressure, I know that the volume will always be 22.4. That's just a constant that you need to get in your brain, and that's the number that we use if it's at STP. Now, will it always be at STP? No. If it is at STP, you should be happy because the math becomes pretty easy. So in order to go from moles to liters or liters to moles at STP, you use this in your conversions. So you would either do 22.4 liters over 1 mole, or depending on which way you're going, 1 mole over 22.4 liters. This would be if you're going from moles to liters. This would be if you're going from liters to moles. Okay. Now, what happens if you're not at STP? Well, if that's the case, you'll be given some sort of you have to be given some information. You'll probably be given a pressure and a volume, and you're asked to find temperature, or you're given pressure, volume, and temperature, and you have to find moles. But if you remember from our unit on gases, we have an equation, and it's called the ideal gas law, and it goes like that: PV equals nRT, or PIV-NERT for short, where P is pressure, V is volume, T is temperature. Those are our 3 ones that we had back up here: pressure, volume, temperature. N, do you remember what that is? That stands for number of moles. And then R is the gas constant. So, and R, there's really three values that we're going to use for R. It's going to have three different values, and it depends on the unit for our pressure. So if pressure is in ATM, we're going to use, then R is 0.0821. If pressure is in kPa, then we use R equal to 8.31. And if pressure is in mmHg or torr, then our R is 62.3 or 62.4. It's, you'll see it both ways, but it's not going to matter that much. So you will always use one of these three numbers for R, okay? And it depends on what is our unit for pressure, okay? What is our unit for pressure? That determines which R we get to use, okay? So as far as a problem goes with this, you have 1, 2, 3, 4 variables that are going to change. This gas constant's not going to change. It's always one of these, but there's 4 variables. So in a question, you will be given 3 of the 4 variables, and you need to solve for the 4th. Okay? So a question might say, a certain gas at a pressure of 1.5 atmospheres and a temperature of 30 degrees Celsius, 30.0 degrees Celsius, has a volume of 5.0 liters. And how many moles would this be? How many moles does that contain? Okay. Well, we're going to use, we know we have pressure, temperature, volume. And in a problem like this, again, it would be written out like in a story form, but it would have these numbers somewhere. And if you're given pressure, volume, temperature, and it's talking about moles, bells and whistles should be going off in your head that you're going to have to use the ideal gas law, the Pivner. Okay? And for whatever reason, they love using this on the free response questions on the AP test. So again, this should be pretty, you should be pretty familiar with this, hopefully by the time we get there, okay? So what I'm going to do, I'm going to simply plug these numbers into my formula. So I know P is pressure, so I'm going to do 1.5, and then I know V is volume. Volume is 5 liters. You need to make sure if it's not in liters, sometimes you'll be given it in milliliters, you got to convert that to liters. In this case, it's given to me in liters. N is what I'm looking for. R is my gas constant. Which R am I going to use? How do I figure that out? I got to go back to here and look at pressure. My pressure is in ATM. So I'm going to use the R value that goes with ATM. So ATM, I'm going to use this number. So I plug that number in here. And then my temperature is 30 degrees. But remember, it's in Celsius, and whenever I do anything with gases, my temperature has to be in Kelvin. So how do I change Celsius to Kelvin? I add 273. So that should give me 303. So that's my temperature in Kelvin, 303. And again, I just did 30 plus 273. Always, whenever you're using this formula, the PV equals nRT formula, the temperature has to be in Kelvin. Okay. So now, from here, it's a pretty simple algebra equation. Just simply solve for N. So I go 1.5 times 5, that would be 7.5. equals N, and then I multiply 0.0821 times 303. And I get 24.876. Okay, we'll round at the end. So you want to keep all your numbers as long as possible. Then we're going to divide both sides by this to solve for N. This cancels. And N will equal 7.5 divided by 24.876. Okay. And we get 2 sig figs here, so it becomes 0.30 moles. So whatever this gas is, there are 0.30 moles in contained within these conditions. Okay, and again, you would, if you're solving for pressure, you use the same equation. It's just instead of the N being the unknown, then the pressure would be the unknown, and you'd have to rearrange it to solve for P instead of N. Okay, but once you get these, the hardest part is getting all the numbers in the right spots, getting the correct R. And then also where a lot of students mess up here is making sure that your temperature is in Kelvin. So be careful with that. Okay. I hope this helps, and good luck.